All right, for this part of the lab, we're going to be looking at soils that have undergone different watering regimes and the effects on soil water content, potential, and the effects on vegetation. So you can see 4 different pots of corn that is being grown. If we go to the first one here, you can see that this one is under completely saturated conditions. It's just sitting in water. It's inundated with water. The second one here is going to be what we would call a moist wet, means that it's watered pretty well, and there's plenty of water available, but not so much that you have standing water or anything like that. The third one is a moist dry. This is where we have water that gets a little bit of water, but not a lot, not enough to meet the plant needs, as you can see. It's going to be drier and harder to maintain the water for plant growth. The last one, where we haven't been watering it, it's completely dry, and we don't have a whole lot of water that's available for plants. So what we're going to be doing is monitoring a couple of different things in each one of the pots. I'll be showing these to you just as demonstration, but then I will be providing you with the data for each one. So I'm just going to be doing demonstrations here. The data will be coming in an Excel file alongside this video. So the first thing that we want to look at is soil water potential. Now remember the gypsum probes that I had shown in the previous video. That's what we've put into the soils, into each one of these. As you can see, they've got the cord coming out and the metal pieces coming out the end. I have the device that I had shown you before that looks at resistance and equates that to soil moisture. So I'm trying to put these on. Hopefully they stay. They're not going to. I can't do this one-handed. But basically that's what I'm going to be doing, is the cord's coming straight from that into this, and then I would press the button. It's going to say 0 because they're not connected. But that's what I would do. That's where the data is coming from. Do it for each one of these. The next set of data is going to be what is your plant condition? There are 3 different things that we're going to be looking at. First is just plant height. So just looking at how high the plants are out of the pot. So I've got a ruler here. Just put it down in the pot and look generally how high the highest leaves are in each. That's simple, pretty easy to understand. The next thing that we look at is plant condition. What do the plants look like, just condition-wise? Is it pretty good? Do they look pretty healthy? Is there any wilting or any other things that would indicate stress? So the first 2, maybe not so much, but the second 2, the 2 drier ones, definitely you have a lot of curling, wilting, signs of necrosis, death. The other 2 look relatively healthy, maybe a little bit of yellowing, but other than that, pretty healthy. So that's the second thing. Third thing, we looked at soil potential using this, the height of the corn, the greenness, or sorry, not the greenness, the condition of the corn, and the last thing that we look at is the greenness of the corn. To assess that, we have a device, Green Seeker. It's a crop sensor. If we turn it over, you can see that there are some of these windows. One of them sends out a laser, the other detects. So if I pull the trigger, see a red light. That red light bounces off the green leaves. The more wavelength that bounces back, the more greenness that is detected. So on this, it'll tell you a number between 0 and 0.9. The closer you are to 0.9, the greener you are. So I'm going to try to give this an attempt. Sometimes we get some errors, so it may take a couple of times. So that's an error. There we go. So we got a number there. If we go over here, we'll get a different number, a little bit lower, so a little less green. those numbers I'm going to monitor for you and give you the numbers. So I was just demonstrating how to use it. All you do is pull the trigger and read the number. All right, so that's looking at the different conditions. So matrix potential, the potential of water, comes from that. Greenness, condition, and height are what we're looking at for the plants themselves. The last thing that we have to look at is soil water content. So to do that, we're going to be looking at gravimetric and volumetric water contents. And to do that, we need to actually measure the weights of the soil, of a certain soil sample. So to do that, over here, I've got a scale with just one of the beakers. Got the weight of that. I'm going to take a sample of soil from these pots just with the spoon. Doesn't matter how much I put in. The starting weight doesn't matter. You're looking at a difference. So I'll just spoon it out, put the soil into the beaker, and then reweigh the beaker with the wet soil. So reweigh the beaker, soil, and water. Then I'll take the beaker with the wet soil, take it over to the other room. Back here, you see that is an oven. I'll put the samples in there, dry them out for 24 hours, and then reweigh the beaker with the dried soil to see what the weight is. The difference in the weight between the beaker and wet soil, beaker with wet soil, minus the beaker with the dry soil, is going to be how much water was in there, because that water would have been lost, the weight is lost. So that's how you can figure out how much water was in there for gravimetric purposes. Volumetric purposes, you use the same number. You can look at the calculations that I'm going to be giving you. You apply the bulk density of the soil, which I will also give you in these slides. But you use the gravimetric water content to be able to figure out the volumetric water contents. Then you use that information to be able to help you figure out the relationship, the curve between volumetric soil water content and potential. So you're going to be making one of the curves that you'll see in the PowerPoint slides, comparing the volumetric water content and the potential, because you need that information to help you figure out what you have for available water, plant available water. So volumetric water content is just how much water is in my soils, but it does not tell you how much is actually available. The matrix potential of the soil particles is going to be sucking, holding on to the water. And some of that water won't be available to plants because the soils are sucking onto it so hard. So that's what we're going to be calculating is relationship of potential to content, and use that information to be able to figure out how much water is actually available to plants. So one last look. These are 4 different treatments. This data will be available to you on Canvas in an Excel file.